Hello everyone. In this video, we are going to discuss about the topic relations from the chapter Relations and Functions of class 11 Maths, which is chapter 2. So here you see we have already discussed about the Cartesian products of sets in our previous video, which will be available in the playlist. So you have to watch that, and after that only you have to watch this video. Okay, because this is a continuation of that. So here you see, if we consider the two sets, one is set P which has these elements A, B, C in it. We are considering another set Q which has elements these Ali, Banu, Binoy, Chandra and Divya. Okay, see, for simplicity, I'm just taking this, I'm going to represent Ali with AL. I'm going to represent Banu with BH. I'm going to represent Binoy with BI, then CH for Chandra and DI for Divya. Alright, so we can write our set Q as AL, BH, BI, CH, DI. Alright, now you see, here we have three elements in the set P, right? We have 1, 2, 3, 4, 5. 5 elements in set Q. So what about the number of elements in P cross Q? What is P cross Q? It is a Cartesian product of the two sets P and Q, which we have already discussed in our previous video. So P cross Q will have elements which is the product of 3 and 5. That is, there will be 15 elements in the Cartesian product of P and Q. What are they? So you see, the elements in P cross Q are these. You see, these are the ordered pairs. You see, 15, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 ordered pairs are there. And you see, while we are writing the ordered pairs, we know that the order is important. So here you see, we have written the first element of P. Okay, in every ordered pair, we have the element of P. The first one is the element of P. And the second elements are actually the elements of Q, because we are taking the Cartesian product of P cross Q. Alright, now you see, so there are 15 ordered pairs in P cross Q. Now let us represent the first element of each ordered pair. First element of each ordered pair with the letter X. That means this X can be A, X can be B, X can be C. And let us represent the second element of each ordered pair with the letter Y. That is, Y can be AL, that is Ali, Y can be Banu, Y can be Binoy, Y can be Chandra, Y can be Divya. Alright, now let us introduce a relation, that is, relation is represented with the letter capital letter R. So let us introduce a relation between the first element X and second element Y of each ordered pair as, so we will get the relation R as set of all ordered pairs X, Y such that X is the first letter of the name Y and X belongs to P, Y belongs to Q. That is, when you write the ordered pair, the first element should belongs to the first set P and the second element Y should belongs to the second set Q. Okay, and here we are introducing a relation, that is, now we are going to write the ordered pairs in such a way that the first letter, the first element of that ordered pair X, that should be the first letter of the name Y. Okay, that is, when you write the ordered pairs from these sets, we have these sets, no? So when you write the ordered pairs from these sets, the first element should be the first letter of the second element Y. So in the new set, you can have this ordered pair A, AL. This is possible. Why? Because you see the first element X, okay, it is A. It should be the first letter of the name Y. So the name is Ali, AL for Ali. So first letter is A. So X is the first letter of the name Y. That is, you see, A, which is the first letter of the second element Y. So this ordered pair is possible here because first element A, it is the first letter of the second element Ali. Okay. Similarly, you cannot have A, BH. You cannot take this ordered pair as per the relation. Why? Why? Because as per the relation, the first element should be the first letter of the second element. So here the first element is A, but the first letter of the second element is B. So this cannot be here in this relation. Okay, so which are the possible pairs here as per the relation? AL is possible. Okay, then BBH is possible. Alright, BBI is possible. Right? Then CH is possible. Okay, only these are possible now. So, the relation, we are getting a new set which will have only these ordered pairs. AAL, then BBH, then BBI, then CCH. Okay, and you see, this is actually, all these elements are actually present in the Cartesian product P cross Q. So, we can write that R is a subset of this Cartesian product P cross Q. And here you see, the second element, it is actually called as the image of the first element. So you see here the second element is Ali, first element is A. So the second element Ali, it is actually the image of A. Banu, this is the element of, image of B. Binoy, it is also, image of B. So the second element, that is actually called as the image of the first element. See, a visual representation of this relation R, that is actually called as an arrow diagram, that is actually shown here. You see here we have the set P, the elements of set P. Here we have the elements of set Q. Now, when we defined that relation R, we got only 4 ordered pairs as per the relation. That is A. Ali, B. Banu, B. Binoy, C. Chandra. So this is how we visually represent the relation using the arrow diagram. And you see, the set of all first elements of the ordered pairs in a relation R from a set A to a set B or from a set P to a set Q, that is actually called as the domain. Okay, the set of all first elements of the ordered pairs in a relation. See, in the relation we got A. Ali, then B. Banu, then B. Binoy, then C. Chandra. These are the ordered pairs as per the relation. So, you see the set of all first elements A, B, C. That is actually called as the domain of the relation R. Okay, so here domain is actually the set of A, B, C. Now, the set of all second elements in a relation R from a set P to a set Q or from a set A to a set B, that is actually called as range of the relation. So, here you see which are the second elements in this relation. Ali, Banu, Binoy, Chandra. So, what about the range of the relation? Range will have these elements: Ali, Banu, Binoy and Chandra. See, we had actually Divya also in set Q, but we didn't write it here while we have written the range. Why? Because Divya won't be there in this range because it is not there in the relation. Okay, as per the relation, Divya is not there. That is how we define that relation. Okay, so range will have only these elements. Then, the set of all second elements, that is a all set B or Q, that is actually called as codomain of the relation. That is in set Q, which is a second set, we have Ali, Banu, Binoy, Chandra and Divya. These are the elements in the second set. So, the set of all second elements, okay, the all set, that is actually called as codomain of the relation. Okay, so codomain will be this set. Okay, so here you see range is actually a subset of codomain. Codomain, right? Because you see range has these elements Ali, Banu, Binoy, Chandra. Codomain has these elements. So all these elements are present here. That means range is a subset of codomain. See, a relation may be represented algebraically either by the roster method or by the set builder method, which we have already discussed in the first chapter. An arrow diagram, okay, that is actually a visual representation of a relation. Now, suppose we have two sets, one is A, another one is B. We have two sets A and B. Okay, then let number of elements in A be P, number of elements in B, that is Q. Okay, then n of A cross B, that will be equal to P into Q. That is the total number of possible relations that will be equal to the the number of possible subsets of A cross B, and that will be equal to 2 raised to P into Q. Okay, see, n of A cross B will be equal to P into Q, that we have already discussed in our previous video. And here you see the total number of possible subsets of the Cartesian product A cross B, that will be equal to the total number of relations possible, and that is actually equal to 2 raised to P into Q. Let us see one example. Here we have two sets, set A and set B. What about the number of elements in A? 2, 1, 2. What about the number of elements in B? 1, 2. Okay, so what about the number of elements in the Cartesian product A cross B? That will be equal to 2 into 2, which is equal to 4. Okay, see, which are they? A cross B will have these elements now, 1, 3, then 1, 4. The first element should be an element in set A. Then 2, 3, 2, 4. So you see there are 4 ordered pairs in A cross B. Then here the number of possible subsets of A cross B, that will be actually equal to 2 raised to P into Q, that is 2 raised to 2 into 2, which is equal to 2 raised to 4. That will be 16. Similarly, number of relations also will be 2 raised to 4. So in this video, we have discussed about the basic ideas of the relations. I hope it is clear to you. Thank you.